Now we are going to learn the KCL and the KVL. KCL is stand for the Kirchhoff's current law. Simply in the KCL, we are considering the node, which is the junction of many currents. Simply the statement of the KCL is it is the sum of current flowing towards the node is equal to the sum of the currents flowing away from the node, or simply incoming current is equal to outgoing current from the node. And this figure, suppose here I1 is the incoming current, I2 is the incoming current, I3 is the outgoing current. So therefore, according to the statement of the KCL, incoming current is equal to the outgoing current. So here the incoming current is I1 plus I2 is also the incoming current. So I1 plus I2 is equal to I3, I4 and I5 are the outgoing currents. So it is I3 plus I4 plus I5, or simply it is I1 plus I2, or here it is a plus I3 plus I4 and plus I5. So to the left hand side it will be minus I3 minus I4 minus I5 is equal to 0. This is simply the KCL. We are applying the KCL at node, which is the junction of many currents. Then now the Kirchhoff's voltage law. Before learning the Kirchhoff's voltage law, we will see the sign conventions to be followed while applying the KVL. Now suppose this is the one voltage source which is having the starting terminal is negative and the end terminal is positive. And suppose I am considering the current flowing from negative terminal to the positive terminal. Suppose this is the voltage V. That means this is the lower potential, this is the higher potential. When the current I going from negative potential or a lower potential to the higher potential, then it is a rise in voltage. Or we are considering it as plus V, because it is going from lower potential to higher potential. Therefore we are considering it as rise in voltage. Suppose this is the resistor and current flowing through the resistor is I. Firstly, we know the Ohm's law. Ohm's law is V is equal to I into R. That means in the KVL, simply we are considering all the voltage sources, only the voltage sources, and we know the resistance. We are having only the resistance, and we have to find the voltage across this resistor. Then we know the value of resistor. Then for finding the voltage across this resistor, we are considering the current flowing through the same resistor. Or according to the Ohm's law, it is V is equal to IR. Therefore, the voltage across the resistor R is equal to I into R. Or we are considering the current is flowing like this. That means we have considered it as starting terminal as positive and the end terminal is negative. That means current flowing from positive terminal to the negative terminal, or higher potential to the lower potential. Then we are considering this fall in voltage. It is fall in voltage. So we are considering it as negative V, or it is equal to minus IR, because the voltage across the resistor is I into R, or it is fall in potential. Therefore we are considering it as negative IR. Or simply this is the another voltage source, and the current is flowing like this from the higher potential to the lower potential, or it is I. Then it is fall in potential or fall in voltage, because it is going from higher potential to lower potential, or we are calling it as fall in voltage. It is fall in voltage, or we are considering it as negative V, because it is fall in voltage. Or here there is a resistor R, current flowing through it is I. According to Ohm's law, voltage across the resistor is I into R. Or I am considering the starting terminal is negative and the end terminal is positive, or the current flowing from lower potential to higher potential. Then the voltage across it is I into R. We are considering it is positive IR, because it is rise in voltage. It is rise in voltage. These are the sign conventions which we are using during solving problems. Now the statement of the KVL is the algebraic sum of product of current and resistance according to the Ohm's law. V is equal to IR. Therefore, it is a product of current and resistance of various branches of closed loop of circuit plus the algebraic sum of all EMFs. All EMFs, or it is simply voltages. EMFs, or it is voltages in that closed loop is equal to 0. That means it is the summation of algebraic sum of current and resistance plus algebraic sum of all voltages or EMFs is equal to 0. This is the simple statement of the KVL. Suppose I am considering the simple loop here. It is a simple loop or a circuit having voltage V1, voltage V2, R1 and R2. Suppose current flowing through this loop is I. Then this is the negative potential or negative terminal. This is the positive terminal. Same here it is the negative terminal. Same here it is positive terminal. The current flowing is like this. So through this resistor current will flow like this. Simply I am considering the starting terminal is positive and the end terminal is negative. Through this it is also current is flowing like this. So suppose starting terminal is positive, end terminal is negative. So according to the Kirchhoff's voltage law, see here the current is flowing like this. Okay. Therefore it is going from negative terminal to the positive terminal. So I am considering it is rise in voltage, or it is plus V1. Then for this resistor current is flowing like this, positive terminal to the negative terminal. Then it is fall in voltage, or it is going from higher potential to the lower potential. Therefore it is fall in voltage, or I am considering it is negative. Okay. So current flowing through the R1 is I and the resistance is R1, and here the current is flowing like this from negative terminal to the positive terminal, or from lower potential to the higher potential. Therefore it is rise in voltage, or I am considering it as positive voltage. Or for this resistor simply it is current flowing from higher potential to the lower potential, so it is negative, or I am considering it is I into R2. It is equal to 0. This is simply the Kirchhoff's voltage law. Now we are going to learn the problem which is based on the KCL and the KVL. The problem is find the value of resistor R when the power consumed by the 12 ohm resistor in the given circuit is 36 watts. It means we have to find the value of this resistance, and they had given the power consumed by this 12 ohm resistor. What is given? Given is power consumed by the 12 ohm resistor. It is 36 watt, and we know the formulas for the power is it is I square into R, or it is simply V into I. We are using here it is I square into R. So therefore power of the 12 ohm resistor is equal to current through the 12 ohm resistor square into the resistance. So it is equal to it is current through the 12 ohm resistor, or power consumed by it is 36 watt is equal to current square. It is current through the 12 ohm resistor. We have to find here the current. We know the resistance, it is 12 ohm. We know the power consumed by the 12 ohm resistor. We know the resistance, and through this we can find the current through the 12 ohm resistor. So it is current through the 12 ohm resistor is equal to under root 3, or it is equal to 1.732 ampere. This is the current through the 12 ohm resistor. So in this figure I am applying the KCL, or I am considering the current through this supply or the battery of 60 volt. It is total current, it is IT. It is coming here to this node, that is IT is coming towards the node. Or suppose these are the outgoing branches, that means incoming current here it is IT, and this current is flowing through 12 ohm, 18 ohm and the 36 ohm. That means suppose this is the current through the 12 ohm resistor, this is the current through the 18 ohm resistor, and this is the current through 36 ohm resistor. So by applying the KCL at this node, we know the incoming current, according to the KCL, incoming current is equal to outgoing current. So incoming current is IT is equal to I12 plus I18 plus I36 is according to KCL. Is according to KCL. Then according to the Ohm's law, we know V is equal to IR. So this formula, through this formula, we are finding the voltage across 12 ohm resistor. So it is voltage across 12 ohm resistor is equal to current into the resistor. That means current through the 12 ohm resistor into the resistance. We know the value of current. It is 1.732 ampere. So it is 1.732 into the resistance is 12. So voltage across 12 ohm resistor is, it is 20.784 volt. It is a voltage across 12 ohm resistor. So in this figure, we know when the resistances are in parallel, so they are having the same voltage source across it. Okay, here the 12 ohm, 18 ohm and the 36 ohm are in parallel, so therefore the voltage across all these resistances will be same. So therefore voltage across 12 ohm is equal to voltage across 18 ohm is equal to voltage across 36 ohm resistor is equal to, this is same, it is 20.784 volt. And again, according to Ohm's law, we know I is equal to V upon R. Here we know the voltages across all these resistances, and also we know the resistance. We know the voltage, we know the resistance, so we can find the current through the resistances. So therefore current through the 18 ohm resistor will be, we were finding the current through 12 ohm resistor, now we are finding the current through 18 ohm resistor. So it is voltage across 18 ohm resistor upon the resistance according to the Ohm's law. So voltage across 18 ohm resistor, it is 20.784 upon the resistance is 18. So it is equal to 1.54 ampere or 1.154 ampere, and the current through the 36 ohm is equal to voltage across 36 upon resistor is equal to the voltage across 36, it is simply 20.784 divided by 36 is equal to 0.5773 ampere is the current through 18 ohm and the 36 ohm. So by the KCL, from this formula, total current is equal to I12 plus I18 plus I36. We know the I12 is 1.732 plus I18 is 1.154 plus I36 is 0.5773. So it is equal to 3.464 ampere. It is the total current. That means this current, total current supplied by the voltage source. Total current supplied by the voltage source. Now here in this circuit, these three resistances are in parallel. So now we are taking the parallel combination of these resistances. Now we are finding the parallel combination of the resistances is, it is 1 upon Rp. Here the 12 ohm, 18 ohm and 36 ohm are in parallel. So 1 upon Rp is equal to 1 upon 12 plus 1 upon 18 plus 1 upon 36. Here the LCM of these three numbers is 36. Therefore 12 into 3 is 36 plus 18 into 2 is 36 plus 36 into 1 is 36. So it is 3 plus 2 plus 1 upon 36. So it is 6 upon 36. Therefore here it is 1 upon Rp. Therefore Rp is equal to 36 upon 6. It is 6 ohm. I am replacing this combination of all these resistances with a single resistor. It is 6 ohm in series with R and in series with 60 volt source. So suppose I am considering the direction of the current is clockwise, likewise, that means current is flowing like this, from this terminal to this terminal, like this, from this terminal to this terminal. Suppose I am considering starting terminal is positive and the end terminal is negative of the current or the resistance. Starting terminal is positive, end terminal is negative. Here the current is flowing from higher potential to lower potential. So it is fall in potential. So it is, I am considering negative, so minus 6 into current IT, here the current is IT. Same here, it is fall in potential, positive to negative, therefore it is negative R into IT, plus the current direction is like this, negative to positive, so therefore it is rise in potential, or it is plus 60 is equal to 0. We know the value of IT, it is 3.464, so it is minus 6 into 3.464 minus R into 3.464 plus 60. By solving this, we get the value of R is 11.321 ohm. This is the final answer.